Okay, so today in this class, we'll discuss question number 33. Okay, this is class 9 science, chapter 8. Okay, so here, derive the equations. Look into your tuition note. It's on page 99 on your tuition note. Derive the equations of motion by graphical method. So we are going to use the graph. The velocity time equation for v equal to u plus at, s equal to ut plus half at square, and then 2as equal to v square minus u square. So let us first write down. We have to derive this equation. I'm just writing in short there. Derive the first equation, famous equation here. V is equal to u plus at. Then we'll go and derive for the next one. S is equal to ut plus half at square, and then the third one, 2as is equal to v square minus u square. So we have been using this to solve the numericals, right? So today we're going to learn how it is derived. So we're going to use graphical method. So you draw along with me here a graph. This is your y-axis. This is your x-axis, let us say. Y and x. Origin is 0. And on the x-axis, we plot the time, let us say, in seconds. And on the y-axis, we plot the time velocity in meter per second, let us say. So we know this graph is called velocity time graph. So basically it's saying by using the velocity time graph, prove these are true. Okay, so let us do that. Now let us consider here an object whose initial velocity is not 0. So 0 is here, so we have to start from above 0, somewhere here maybe. So this point, let us say A. This point A, it is having initial velocity u. And we know clearly now u is not 0. So when we first saw this car or object moving, it was already moving. It was not starting from rest. That's what it means. U not equal to 0 means the object initial velocity was not at rest. Okay, so let us say its velocity increased uniformly. Now in the previous class we learned that the graph for uniform acceleration is a straight line with an upward slope. That means the velocity is always increasing by equal amounts in equal time. Then only it's a straight line with an upward slope. So we have to make sure that we take the motion of an object which is in uniform acceleration. Means these equations will be true only when the object is moving with uniform acceleration. It is not true for non-uniform acceleration. Okay, therefore it has to be a straight line, and it reached this point here, let us say this point here, and this point is the final velocity, let us say v, and this is the b point. It reached this b point. Now this final velocity is v. So let us write down, take or consider an object. Okay, take an object, take a velocity time graph, take a velocity time graph for an object or body like a car. Okay, vehicle for an object moving under, this is very important, under uniform acceleration A, let us say. So this equation will be true only for uniform acceleration. Means an object whose velocity is increasing or decreasing by equal amounts. Not for uniform. This is not applicable for uniform motion. It is for uniform acceleration. For an object moving under uniform acceleration A, okay, where or such that where initial velocity is not equal to 0. That means the object was not at rest in the beginning. So with this we will write here here, therefore we see here, we see that initial velocity is u. Okay, initial velocity here is u at the point A, which reaches finally, increases and reaches the final velocity v in a time period or in time t. So its initial velocity is u at A, and it reached the high velocity of v, final velocity v, in a time period of t. That means this one here, if you draw perpendicular, is the time period from here to here. 1, 2, 3, 4, 5 seconds. So how many seconds it took, we don't know. That much time it took to reach this final velocity. That's what it means. So here we have this one. Now let us right here draw. So from here we come, draw perpendiculars. Okay, perpendiculars BE. Let us say this is BE and this one is BC. BE and BC on the velocity and time axis respectively. So that is our construction. So we're going to draw from here BE perpendicular to the y-axis, which is the velocity axis, and BC perpendicular to this x-axis, which is the time axis, okay, respectively. Then finally draw this one. Draw here, from here you draw another perpendicular. Let us say here AD perpendicular to this one here BC. So this is our final construction. Having done this, we'll start the proof for A. Now in our previous classes, towards the middle of the class, we have discussed that acceleration is equal to formula. Basic concept is change in velocity divided by the time taken. Whenever an object is changing its velocity, that is called acceleration. If the object is not changing the velocity but moving in uniform velocity, that is zero acceleration. But acceleration is change in velocity divided by how much time it took for the change in velocity. So this is the one. Now we know that here change in velocity, this is the velocity graph, this side here, see, velocity value. So this change in velocity is as it moves from here, see, to here. The velocity was here u, value u, and when it reached this b, it became v. So the change in velocity is this much, which is the BD, divided by, to reach from here u to v, B point, it took the time, as you can see here, t. So we write that one, BD by time period of here, this one, BD by this. To reach from here to here, it took a time period of 1 second, 2 seconds. AD, so we write here AD. Let's keep this one as 1. Now let us see this one, BD first. We know that BD is clearly equal to EA because we know opposite sides of a rectangle are always equal to each other. You see here, this one here, BDAE is a rectangle, and BD and EA, these two are opposite sides, and opposite sides of a rectangle are always equal to each other. So we can write here that is this BD, which is already proved equal to EA, is nothing but, see here, EA can be written in terms of EO full line minus AO. EO minus AO. So that will be equal to EO is from here to here is V, final velocity V, minus AO is the value, initial velocity U. So we got this one. This is equation number 2, let us say. Now again, we also know that this one here, AD is equal to here OC, because of the same reason, opposite sides of the rectangle. This time, this one here, this rectangle, right? So AD equal to OC, sorry, so this rectangle here, see, this rectangle, AD equal to OC, this side, opposite sides of a rectangle. Now once you are done with that, AD equal to OC. Okay, this is not OC, this should be, yes, so O, this is actually 0, okay, you put here O. So this is the English letter O, and this is the number 0, 1, 2, 3, 0 value. So add that one on your tuition note also, it's missing O here. So here this AOCD rectangle, this here AD equal to OC. Then we can write here AD equal to OC equal to here, see, OC is the time period from 0 to t seconds, so this is t. So this is equation number 3. Now let us say putting equations 2 and 3 inside or in equation number 1. What will we get? If you put this value 2 and 3 in 1, you will get A will be equal to BD here, V minus U divided by, here you see AD is equal to T. So that's the meaning of putting the values of equation 2 and 3 inside 1. So as we proceed doing this, you're going to get here, that implies, as you cross multiply, A into T is, okay, V minus 1 into 1, here 1 is there, cross multiply up and down, V minus U. Okay, V minus U. Then T into A is TA or AT. Then here V don't move. If you move this minus U, this side become plus U. No sign here means already plus is there. So the first formula is proved. V is equal to U plus AT. By using this velocity time graph, we have proved. So that is called graphical method. Okay, so let's go to the next one, B. So we finish this one. Let's go to B. So B here is, we have to prove S equal to UT plus half AT square. Now, just in the class, just before this, one class just before this, we have known that when we have this velocity time graph, the distance, okay, we know from our previous knowledge, that means we know the distance traveled, which is usually denoted by the letter S in this chapter, is given by the area under velocity time graph. We have learned this in the previous class, that the distance traveled by an object between two time periods from here to here, whatever, is given by the area of the figure under this graph, straight line. Therefore, S will be equal to area under this graph, is this straight line, is AOCB. And you know these two lines are parallel, you see here. This and these are parallel. So if two sides are parallel in a four-sided figure, that's called a trapezium. So you can write here area trapezium AOCB. AOCB. And we know this can be broken down into area rectangle AOCD plus area, this trapezium here, full one, can be written as plus this one, triangle ADB. So we write like that. Then rectangle area is length into breadth. So you can write this one OC into AO or AO into OC, whatever. So you write here length into breadth, that's fine. And area of triangle is half into base into height. We know this is perpendicular, so base will be AD, then the height will be the one perpendicular to AD, is this one BD. Area formula for area of a right triangle. So now we very easily know that AO is already given here. AO value is U. Okay, U into OC also. The time value here, see, this T. One to here OC, so T. So U into T plus half into AD into BD. Let us put this one as equation number 4, following the last one, 3. Now here, we know that AD, let us deal with this one. AD equal to here, OC. Because we know there are opposite sides of a rectangle are always equal to each other. So that will give you AD equal to, that implies OC, and OC we know already is T, so this is T. Equation number 5, let us say. Then we go and deal with this BD here. So let us write that BD here is equal to EA. Because of the same reason, that is, they are opposite sides of the rectangle EADB. So they are equal. Now as we continue, we'll come up here. So that will give you here BD is equal to EA is equal to, here now EA can be written as EO full line here minus AO. EO minus AO will give you this AE or EA, this one. So EO is the final velocity V minus AO is the value U, initial velocity. So you can just give it as equation number 6. Then we'll write here, putting equations 5 and 6 in 4, then what will we get? If we do that, 4 is here, see. So we write here UT, oh sorry, S. Here S was there on the left side, right? S equal to UT plus half into, here you see, AD. Just now AD has been found to be T, so we added T into BD, and BD has been found to be V minus U. Just write here V minus U. Right, so that is what we get. Now, as we get this one, UT plus half AT square, let us put this one as equation number 7. Now, but we also know the first equation, V is equal to U plus AT, already solved, right? So we want to change this one into that form of this one. So V, and bring this one this side, minus U equal to AT. So this is equation number 8. So if you put here, putting equation number 8 value in 7, then what will we get? We will get like this, right? See here, V minus U, here we'll put, so S equal to this one, same, UT plus half T into V minus U, we can replace by AT. That's the meaning of putting this 8 value V minus U inside here. So that'll give you S equal to UT plus half, we can write A first and T into T squared. So hence proof the second one also. This one proved, and this one proved S equal to UT plus half FT squared. We have found out that this is true by using the graph. Finally, let us do the C, the last equation. Again, we know from the class just before this that distance traveled, again, because the last equation is having S, distance traveled. S is given by the area under velocity time graph, the area of the figure under velocity time graph, to be specific. So here S will be equal to area trapezium AOCB again, just like we did for B. We will use this same trapezium for B also, AOCB, but we will this time use in a slightly different way. Now in your class 6-7, we have learned that area of a trapezium is like this. Trapezium basically is a four-sided figure like this, in which two sides are parallel, and the other two may be parallel, may not be parallel. So here the figure is like that. See here, this figure AOCB is AO parallel to BC. So we know that in a class 6-7, area of a trapezium is half into the sum of the parallel sides. The parallel sides are AO plus parallel to BC multiplied to half into sum of the parallel sides into perpendicular distance between these two parallel sides. The perpendicular distance between these two can be AD also or OC also. We prefer this is the perpendicular in 90-degree distance between the two parallel sides, AO and BC. So we'll prefer OC. So just write like that. Now as we continue to do this, we will get here half into AO, where directly given U, plus BC. BC is directly here equal to EO, right? So we just write your BC into OC. OC is directly given here T. So let us put this one as last equation was, let us say, last equation was for 7, 8 like that. Okay, just begin like this. Just see it separately and put equation 1. Then what we will get is we need to deal with BC. So BC is here. Basically, we can write here, but BC is equal to EO because they are opposite sides of a rectangle are always equal to each other. So that gives you BC equal to EO equal to BC equal to EO equal to this value V. So write your V. So if you put this as equation 2, you may as well write putting equation 2 value in 1, we will be getting here this S equal to half into U plus BC. Just now we got V into T. So that's what we will get. Let us put this one as equation number 3. Okay, then here we're going to have to get 2A is equal to V square minus U square. So let us do something about this T. So here, but we know the first equation, the famous one, V is equal to U plus AT. So from here, let us get your T. So that will be AT, don't move that, or you can just put it this side if you want, same thing. T, don't move, AT is equal to, then here V minus U. V, then this plus U come this side, minus U. That's what we'll get. So that will give you, don't move this T, then V minus U divided by A come down. That is, in other words, T is equal to V minus U by A. V minus U by A. Let us put this one as equation number 4. Now putting this here, putting this equation 4 value, which we got just now, in 3, we'll get almost the final answer now. 3 here. S equal to half into U plus V into T, and T can be replaced by V minus U divided by A, right? So you can put here, next point, next step, here. If you shift this 2A down, it will go up and multiply S and become 2AS. We'll do this. then you're left with u plus v. We can write v plus u also, same thing only. See, v can come from, no sign means plus u, into this one, v minus u. So finally we will get 2as equal to a plus b into a minus b. We can write as a squared minus b squared. So hence proved. So these three famous equations for motions have been proved. Remember, these three equations are true only for a body that is moving under uniform acceleration, means velocity is increasing by equal amounts or velocity is decreasing by equal amounts. It does not apply for objects that are moving under non-uniform velocity. Okay, it is very important. It comes frequently in the class, in the exams, so please be careful about it. Okay.